Hi guys, I'm just gonna start with this talk on what angles of, well, angles between two lines rather. So let's suppose you've got two lines here and the question says to you, well, find the size of this angle here between the two lines called angle alpha, all right? So what you've got to do, guys, is you need, remember, for us to be able to know whether this thing is going to be obtuse or what, we're going to need that horizontal line. We're going to need the x-axis, in other words, okay? So what's best to do is to draw a line, okay? And when you have drawn this line, you actually just place it at the point of intersection for the two lines. That's what you gotta do. And let's just have a look at what happens here, maybe before we take an example. Now remember, we measure positive angles anti-clockwise, okay? So if I wanted the small angle here, this angle, then that I can call it theta, maybe let's say theta 1. And then if I want this big angle here, and I can call that theta 2, all right? Or maybe I should call it beta to avoid confusion. Maybe let's call this one beta, this one theta, that one alpha. Now, I hope you can see that alpha is the difference between beta and theta. Okay, hope you can see that. Right, I took off my line, let me bring it back. So here is theta, and it's in there. Then maybe I'll use a different color to denote beta. Here is beta, and it is that angle there, all right? So this is beta. So I hope you can see then alpha is the difference. So this portion here. So in other words, alpha plus theta, another way to see this is to see that alpha plus theta will give you beta. So that's where we take this equation from, because then you just take theta to the other side, then you have that. All right. Now, let's suppose, for argument's sake, let's say for argument's sake, the equation of the two lines are given, and we can see they're both positive, right? But not that positive. Well, in other words, the other one is more inclined. The other one is less inclined. Yeah, that's kind of what I meant. All right. So using this concept, let us take an example here in which we have two lines. Ne? So here is one with a negative slope. Here is another with a positive slope. Fortunately, we are told the equation of this line is y equals to minus 2x plus 3. That's what we are told. And then here we are told that the equation of this line, y is equal to x plus 2. And this angle here is what we are looking for. So let's call it alpha. So remember, what was the trick? First thing, I need to have that x-axis, that line on the x-axis, so to say. So let's do the analysis. I'm going to have the analysis here. Then I must just make sure this line passes at the point of intersection of the two lines. And then after that, I can now start by analyzing. So here, I'm going to have my theta. My theta is this angle here, so which is between the red line and this straight line. And then I'm going to have my beta. Remember, positive angles are measured anti-clockwise. So this big one here is going to be definitely my beta, right? And I am looking for this angle here. We have established that actually alpha plus theta equal to beta. And so if I'm looking for alpha, alpha is actually beta minus theta, right? Now, this is now the important part. You must notice that this theta here is an acute case, right? And you need to notice that the beta is an obtuse case. So I hope you remember that in an obtuse case, we're gonna take whatever angle we have, okay? Angle, in fact, let me not say angle. You're gonna take arctan, okay? Arctan of the gradient, and you're going to add 180. And remember, the gradient here is negative. In an acute case, you're just gonna take arctan of the gradient, and the gradient is positive. I hope you remember these important fundamentals. So now let's answer the question. Now, I can see clearly here that the gradient is positive and it is actually 1. So for this line here, okay, m is actually 1 and this is positive. For this line, the gradient is -2 and -2 is obviously negative, you know. Now, let us start with the first case, that is the obtuse case. So if I take arctan here, so arctan, you can just punch -2. The calculator should be able to give you a nice answer there. So I think you're going to get something like arctan of -2 is, maybe I should start writing this in a nice formal way because you guys are starting. So let me start by saying, well, tan theta equals to m, so that you can get where this is coming from. Now I have that tan theta is -2. Now if I want theta, theta is arctan, okay, of -2. Now, as a matter of fact, I should stop now being stereotype as well and say beta because we are using angle beta. That's how we have labeled it there for that big line. So beta is that. So beta now is, if you take arctan, 116.57 degrees, okay? Similarly, I am going to say, well, for the positive line, tan what? Theta in this case is equal to 1. I hope you know your special angles. So theta is 45 degrees, right? Therefore, alpha, by this equation, alpha is 116.57 minus 45. And that is 71.57 degrees. So this is generally, guys, how you are going to look for an angle that is hidden somewhere between two lines. Cheers.